I'm Hannah McGee.
I'm Cheyenne Markley, and we're doing Venus as our planet.
So, to get to know Venus, Venus is the second planet closest to the Sun. It is often called Earth's evil twin sister because it's very similar to Earth, but it's inhabitable because of the temperature. And Venus is also classified as a terrestrial planet because it's solid and close to the Sun.
What's it like on Venus? Well, the size, Venus is a little smaller than Earth. It is about 638 kilometers smaller than Earth and has 81.5% of Earth's mass. The surface contains volcanoes, craters, mountains, and big lava plants all over the surface. We cannot see the surface from space exactly because Venus is covered in thick clouds around it, and it's made of sulfuric acid. But it also smells like rotten eggs.
Because of the sulfuric acid in the clouds. Okay, so the temperature on Venus is very, very different from Earth. It's the average temperature is about 900 degrees Fahrenheit, and that temperature can literally melt lead. The atmosphere of Venus is very thick. It's very different from Earth because on Earth, compared to Venus, if you were 3,000 feet below the ocean, you would be feeling the weight of Venus's atmosphere.
The rotation and time of Venus, all the planets rotate counterclockwise, but Venus is the only planet that, other than Uranus, that rotates clockwise. Venus has the slowest rotation of any planet in the solar system. It takes about 117 Earth days to rotate. That is 1 day on Venus.
So the orbit, it takes Venus 225 days to orbit around the Sun, and Venus orbits in a more circular pattern than Earth because Earth is more oval and yeah.
Okay, the cycles of Venus. At first, people such as Aristotle thought that Venus didn't orbit around the Sun, well, technically the Earth, since that was what it believed back then. And instead, they went around in epicycles on like a perpendicular line to Earth, technically speaking. It wasn't until Galileo took something similar to a telescope, not an official one, but similar to it, and he watched for almost a year or maybe more, and found out that Venus had different cycles. Therefore, it had to orbit around the Sun, since we see either the full side of it, which was where it was very bright, or a crescent side of it. And just like on here, it's very similar to how our moon cycles are. So we had the current and past missions we had were like, they're all listed over on that side. There was the ISA Venus Orbiter, where we went around Venus to look around it, which we did a lot of those. We did a radar mapping of Venus, and in the 1969 and 1994, and we did a lot of those as well. We did many others, such as contained that are a lot like those mainly, and then we have a future mission coming up.
Discovery. So there's a recent discovery on Venus that the surface is extremely hot and the conditions are very different at a different altitude. So at 125 kilometers above the surface, the temperature is actually negative 175 degrees Celsius, which is very unexpectedly cold considering how close Venus is to the sun. Earth versus Venus. Okay, so this is comparing Earth and Venus. Earth has people on it and it's habitable, and Venus is not. Earth has an elliptical orbit, which is oval around the sun, which rotates oval around the sun, and Venus has a more circular orbit. Earth has a liquid core, and Venus has a solid core, and Earth is 93 million miles away from the sun, and Venus is 67 million miles away from the sun. Earth has one moon. Venus has no moons. The radius of Earth is 3,963 miles, while Venus is 3,760 miles. It's very, very similar.
So, what we don't know and what we want to know about Venus, there are like three main goals that we have for Venus, and that is, one is the atmospheric formation, the evolution, and the climax history of Venus. They kind of include just the energy balance, the greenhouse, superrotation, evolution, clouds dynamics, and haze history of Venus. The second goal we have is the evolution of the surface and interior of Venus, which just includes the heat release of Venus, the resurfacing and internal differentiation of Venus. And our third goal is the interior, surface, and atmospheric interaction, which is, was or is there any liquid water on Venus that we can find?
So what is Venus made out of? Venus is made up of an iron core and a rocky mantle, very similar to Earth's. The air consists of carbon dioxide and nitrogen and other small amounts of other gas. The clouds are made of sulfuric acid, as you know. And what happens is the greenhouse effect happens, and the clouds trap carbon dioxide close to the Earth, close to the planet, making it extremely hot. This is the greenhouse effect.
Okay, so who found Venus in general? There was no one person that really got the credit for finding Venus, but the knowledge was always existent throughout the ancient civilizations that Venus was there. It wasn't until around 1610 where Galileo pointed his somewhat telescope, like I explained earlier, to the sky and found that Venus went through different cycles, and proved Copernicus's theory that Venus is an actual planet that moves around the sun.
So moons, Venus does not have a moon, and the reason is because if Venus had a moon, if it was too far away from the planet, the sun would pull the moon out of its orbit and pull into the sun. But if the moon was too close to Venus, then it would be destroyed by the tidal gravitational forces of the planet. So if Venus had a moon, it was destroyed. The inner core, so Venus has a crust about 50 kilometers thick and a mantle about 3,000 kilometers thick. and a core about 3,000 kilometers across. But because of the heat and the thick clouds on Venus, it's very difficult to understand the inner core of the planet. So the scientists believe that Venus has a solid core based on the density of the planet, and that the planet has no magnetic field around it.
Okay, so are there any changes really on Venus? There is a cyclone on the south pole of Venus that, and it always breaks apart and then reforms. According to new research though, scientists have been studying observations of Venus for about 6 years or more, and have concluded that the storm, the long-lived storm that's been happening, is consistently evolving, and it's raising more questions about Venus's usual weather patterns that it has.
The magnetic field, so as I mentioned before, Venus does not have a planet-wide magnetic field. Then scientists believe that the magnetic field on Earth is caused by the convection of liquid in the core of the planet. And since the reason Venus does not have a magnetic field is mainly because of its slow rotation and the lack of internal convection in the inner core. So the inner core is not rotating fast enough to generate a magnetic field for the entire planet. So mysteries. There's a mystery called superrotation. About 60 kilometers above the surface, there are 250 mile-hour wind, and that makes the atmosphere rotate around the planet, which is very, very mysterious. The planet itself is 4,000 million years old. 4,000 million years old, and the surface appears to be only 500 million years old. So that brings up questions like, did Venus resurface? Is it still resurfacing? The entire planet, okay, here's some questions. Is the entire planet a single crust, or is it continental plates floating on the molten interior? That's a question. And then one of the most mysterious mysteries is there's holes in Venus's atmosphere. So when the sun, like solar flares, the solar wind hits Venus, and somehow it creates some holes in the atmosphere. And we'll watch a video on that. Yeah. Is the sound up?
Yes.
Venus doesn't have a magnetic field. So Venus is just this big rock with this atmosphere, the ionosphere, sitting in space, and this super solar wind with the interplanetary field whacks into Venus, and it can't penetrate through the ionosphere. So the interplanetary field lines just sort of pile up.
Wind whacking into it essentially sort of strips off the atmosphere, and it literally forms this long tail, like a comet that's stretching out into space. Pioneer Venus Orbiter was the first spacecraft to really thoroughly explore that night side region where the atmosphere is all escaping away. And it discovered this really mysterious phenomenon which has yet to really be explained. Imagine that we're flying from pole to pole on the night side, so we're feeling the plasma around us, and then suddenly the ionosphere disappears. And then it sort of comes back. And this is what an ionospheric hole is. It's like a chasm in the sky, a big hole where the ionosphere is just absent. The Pioneer Venus Orbiter basically measured inside these things, and we saw that there is very little plasma, and there's all this magnetic field. And from that, they sort of suggested that this is essentially a magnetic structure that's sitting in the night side. I wanted to see if I could go looking for these things with Venus Express. What we saw is essentially this really exciting, strong, straight magnetic field line that we expected, and really boring plasma signatures that shows us that this is a magnetic structure, right? This is a tube of interplanetary magnetic field that, well, PBO saw it coming out of the ground, and now we've seen it way out in space. So these things really continue out to much higher altitudes than we previously found. And the other thing that's important is, well, Pioneer Venus Orbiter only saw them during solar maximum, when the sun was really disturbed and really blowy and stormy. But we've now been seeing them all throughout the solar cycle. There's sort of two explanations for what might be causing this. One possibility is that so these field lines, and they come in from space, and they get sort of stuck in the ionosphere. The ionosphere sort of flows from the day side to the night side. And as it goes around, it sort of meets this plasma that's in the tail, and there's sort of a pile-up between the two. So that's one idea. And the other idea is that on the day side, the field lines come in, and they actually sink through the ionosphere, go through the rocky mantle, and they get hung up on this big metallic core. These field lines essentially end up draping around the core and stick out the rock at the back. One of the main differences between Venus and the Earth is simply that Venus doesn't have a magnetic field. So the way it interacts with the star is completely different. If you want to understand how did Venus get that way, why does Venus not have any ocean, you need to